guys, let's solve this one. 3.3. So for this problem, we're going to use nodal analysis to determine current Ix and the amount of power supplied by the voltage source and the current. So for this one, to know the power, we've already got voltage. We need to know the current going through this wire here. Okay, so that's one thing we have to find. And then what's the other thing? Ix, which is current coming down here. All right, so let's solve this. So we're going to use our 5-step process. First part, 1, draw ref nodes. Where's our reference node? Let's just draw right down here. There we go. This whole line is ground now. Cool. Now 2, this whole line is 0 now, I should say. 2, assign voltages. All right, so now we're going to look at what we got. So let's look. If we put one here, okay, that looks good. If we put one here, that looks good, but there's nothing in between them. So we're just going to make this whole chunky thing V1. That looks good to me. I'm cool with that. Any other nodes we want? So this is a current source, so that's just going to come in. This one is a voltage node too. That's an easy one, but I'm going to call that V2. All right, that looks good to me for that one. 3, what is 3? We're going to assign currents coming out. Assign currents out of nodes and label. Cool. Currents coming out of the nodes. So that's going to be our I1. Cool. We've got I2. We already have Ix. I'm just going to call it I3 for now. Doesn't matter. I3, Ix. Okay. On this one, we're going to call I4. Cool. We have them all coming out. Good. 4. Solve easy nodes. Do we have any easy nodes? Yes, we do. We have a single one up here. So V2 equals 40 volts. Bingo. I like that. Cool. Now, what's our next one? 5 KCL at other nodes. Okay, KCL other nodes. We have only one other big node here. So I1 plus I2 plus I3 plus I4 equals 0. Remember, I3 equals Ix. I'm just renaming it. Make it a little simpler with convention. Makes it easier for me to make sure I didn't make a mistake or something. So for I1, what do we got? I1 is going the opposite of a current source, a 9 amp current source. So I1 equals -9. That one's easy. Plus I2, we've got a resistor and we've got a drop from V1 to 0. And that's going to be 2. So we're going to do plus V1 minus 0. So I'm not going to write it. And then we've got a over 2. Cool. Next one. We've got a V1 over here, and we've got a 0 here, so it's V1 minus 0 over 4. V1 over 4. No need to write the 0. And then we've got I4 over here. So we're going to have V1 minus V2 over 8 plus V1 minus V2 over 8. And that's going to equal to 0 for that node. V2, we already solved, equals 40. You got to plug that in. So we're just going to cross that out. Blah, 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 equals 40 minus 40. Remember that. Cool. And now we're going to what? Multiply this by 8. Multiply by 8. So let's do 8 times 9 minus 72 plus 8 divided by 2. 4V1 plus 2V1 plus V1 minus 40 equals 0. Collect like terms. So we got 72 and 40, gonna be 112. And then 4, 6, 7. V1 equals 112. V1 equals 112 divided by 7, 16. Yeah, that looks about right. Cool. So we have the first bit of this one. Move that out of the way. We're gonna move this up a little bit more. So what else do we got? What's the question asking again? Determine current IX. Okay, it's easy. So IX equals I3, and I3 is going to be, well, we can solve that. We have a voltage here, we have a current coming down, we have a ground, so IX equals I3 equals, what is that? V equals IR, right? We're just gonna box that. V equals IR, and that's the voltage here, which is V1, so 16 equals I, because we're trying to find the current, and 4, R equals to 16 divided by 4. Cool. Oops. I equals 4, excuse me, because we already have R. I equals 4. 4, 16, cool. So 4 equals IX equals I3. That's one of our answers. Cool. And do we have anything else we have to solve for this one? Oh, yeah. The power supply by the voltage source. Cool. So first you're going to need to find the current to be able to find the power. P equals IV. We're missing the I. We have the V. So for I4, we are going to have, we can do a V equals IR there again. So what do we got for I4? We know it's this piece minus this one over 8. So I equals V1 minus 40 over 8. Okay, because I mean, we already had that up here too, by the way. So I'm just pulling this piece out right now. And we're going to plug in our V1, which is 16. 16, I'm just going to write it over a bit. There we go. 16 minus 40 divided by 8 equals minus 3 amps. So that means the current is going this direction. Makes sense because the source is coming this direction too. So, and then power equals IV, and our power equals our minus 3 times, what is this, 40 volts? 40 equals minus 120 watts. Cool, that looks good to me. This means it's supplying power. We did that in the first test. So, supplying power, not receiving power. Looks good to me. Everything looks good there. Yeah, first one done.